Okay, as I was thinking about you all and thinking about how I want you to study and prepare for a test, and I really wanted today to go differently. I really wanted today to be a day where you had already done practice problems and you were coming in and asking me for questions. And you may have had some, and I may not have given you time to ask them. But instead, I wrote down topics that I wanted you to be sure you were comfortable with, and I went over a question from each topic. So what I'd like for you to do is I want to run through at least a section or two of how I want you to study for this test. So I want you to open your book to page 96. And we're going to do section 2.1 first. At the same time, you should have your notebook open, and you should find the homework we did from section 2.1. Because the only questions I would have on the test were questions similar to homework questions. And so I think the first homework questions that you come to that match a topic that we had on the board today was 9 through 15. And the wording's a little different. It says, describe how the graph is related to y equals x squared. This is the transformations. So if you did number 10, now let's do number 12. Now, for you to study for this independently, you should do some of the odds because we have the odds answers in the back, and chances are we work the odds in class, and you have them for homework. But since I'm going to leave you with problems that you can still practice, I'll do number 12. So how does this compare to the parent function y equals x squared? Well, this negative is a reflection on the x. The 3 is 3 units left. And the 1 is down 1. So you should try the questions in this section here, not just one of them. See how the one I did with you in class just had a left or right transformation and an up or down transformation, but this number 12 that I chose has a reflection. So you have to try several so that you get an example like all the different scenarios that are possible. So just trying one isn't enough. You need to try some of 9 through 15. And then identify the vertex of a function. That's got me looking at problems 17 through 29. So if I want to identify the vertex, I'm going to complete the square. I'll do number 18. So this one is a little different. You could move the 7 over if you wanted, or you could think about this as having a 0x. And if you'd like, you could move that 7 over. So to complete the square, you do b over 2 squared. So you're going to add a 0 on both sides. And you get 7 equals, we want to factor this, but it's x squared, right? Or if you could factor it as x plus 0, x plus 0. So if you really wanted to follow through with it, you could call that x plus 0 squared, and you could move your 7 back over. And then it's really nice for you to see that your vertex is 0, negative 7. Let's see a different one. It doesn't work out quite the same. Let me do number 26. Alrighty, I'm probably going to move the 1/4 to the other side. And I've got my b over 2 squared, which is 9/4, and we're going to add that to both sides. 9/4 minus 1/4 is 8/4. And this is going to factor x and x, and 3/2 and 3/2. When we were practicing this in class, I was saying just do the square root of this and do the square root of this. And someone noticed that this number that goes here is always this b over 2 that we do. And that's all true. Now 8/4 is 2. And x plus 3/2 times x plus 3/2 is x plus 3/2 squared. And then you just want to move your 2 back over. So your vertex is -3/2, comma, -2. And then I did one with you like 27, 28, 29, and 30, where you had to factor out the leading coefficient first. So you should try 27 or 29. Next, let's see. Next topic. That 31 through 35, those are good just factoring questions if you have questions with factoring or want more practice. But when you look for 39 through 43, those are that, given the point, given the vertex, write the equation in standard form. I'll do 44 because it's got all the fractions. This is my vertex. And my point is 0. This is my xy. Well, this is my point. -1/4, -1. Okay, so my vertex is my hk. My point is my xy. So I have the equation y equals a, parenthesis x minus h squared plus k. And we'll plug everything in and we'll find a. So we've got -17/16 equals a times 0 minus -1/4 squared minus 1. Add the 1 to both sides. -17/16 plus 1, you can do that on your calculator, or you can think about that being +16/16. So that's a -1/16 equals a times, this gives us a 1/4 squared. -1/16 equals a times square that 1/4 and get a 16th. I'm going to multiply by the reciprocal here on both sides. And the 16s cancel and you get -1 equals a. I guess really you could have just looked at it and said -1/16 is a times what times +1/16 and gotten your a. I wasn't thinking about it. So now we go back to our original, y equals, we plug our a in, and we plug our vertex back in. And I think that's it from this section. I don't think anything else was covered by any of the topics I put on the board. So let's go to section 2.2. Now, I do not think what I just did with you is enough practice on section 2.1, unless you really feel good about completing square, even with the leading coefficients. You really feel good about writing the equation, and you feel good with your transformations. All right, section 2.2. Let's all turn in our books to page 109, and I hope you have your homework out. You know the questions that we've done on this page. 17 through 21, that's more transformations if you wanted more practice with those. End behavior. Let's look at comparing end behavior. 23 through 28. That was a topic I put on the board. So let's go with comparing end behavior. Use a graphing utility. Oh, no, I don't like those. I don't like those. Let's turn the page and look at 29 through 36. Apply the leading coefficient test to describe the right hand and left hand behavior. I'll do 34. Looks complicated. F of x equals 3x to the 7th minus 2x to the 5th plus 5x to the 3rd plus 6x squared all over 4. Well, that's kind of strange looking, because usually when we do leading coefficient tests, we have a polynomial, and now we've got this polynomial over 4. So why don't we do some giant rewriting of some I love math so that we can write these as like fractions. So 3x to the 7th over 4, that's the same thing as 3/4 x to the 7th. And then we've got, negative 2x to the 5th over 4. That's the same thing as negative 2/4 x to the 5th. 5x to the 3rd over 4. That's 5/4 x to the 3rd. And 6x squared over 4. That's 6/4 x squared. Now you can reduce those fractions if you like, but I was really just putting it in a nicer form so that I can talk degree in leading coefficient test. So my degree is the highest power of x, so it's a 7th, which is odd. Odd degrees behave like x cubes. My leading coefficient test, the leading coefficient for that term is 3/4, which is positive, which does not flip our graph. So this is the graph we're looking at. That means left and right. The left, as x approaches negative infinity, y approaches negative infinity. The right, as x approaches positive infinity, y approaches positive infinity. You might say the left falls and the right rises. You might say the left decreases, the right increases. Those are all great. So try some of those and see, compare with the back of the book and see if you're getting them right, or compare with your own answers. 37 through 48, finding the zeros, that was a huge topic for us. Let's do 42. G of t equals t to the 5th minus 6t to the 3rd plus 9t. Finding the zeros. I'm going to try to factor if I can. I want to try to factor. And this has a GCF of a t. So let's factor a t out. Whoops, not 9t. Now this is one of those quadratic-like problems, because instead of it being x squared plus an x plus a constant, where this is 1 and this is doubled, now it's x to the 4th and x squared and a constant, where this is 2 and this is doubled. So it's quadratic-like. So we're going to factor it as if it, similar to quadratic. We'll do t squared and t squared to get that t to the 4th. And factors of 9 that'll give us a 6 will be 3 and 3, and they're both minuses. They wanted us to find the zeros. Now these do not factor more. So one of the zeros is this. T is 0. And this factor, t squared minus 3 equals 0. Add 3. Take your square root. So t is, t is plus or minus the square root of 3, since 3 won't break down. I had 2 of those. So these have a multiplicity of 2. Each of them do. And there was only one factor of this, so it had a multiplicity of 1. They didn't ask about multiplicity, but I just thought I'd throw it in there for us. Another one. Well, that might be all I'll do there, but you have odds there that you should practice till you feel really good about these. 49 through 57 is more finding real zeros, doing multiplicity, so you can practice those. Let's look at 65 through 73. That's a topic I talked about today. Finding the function with the given zeros given. So let's say we had number 68, and we had zeros of 0, 2, and 5. That means x is 0, x is 2, x equals 5. If they're my zeros, they're my solutions. So what are the factors that these came from? This is just an x factor. This is x minus 2, and this is x minus 5. Put a little f of x in front and an equal, and that is your polynomial function. You do not have to multiply it out for me. I'll just tell you right now, I'm not going to do problems like 71 and 73. Not on this test. I will hope to cover them on the 2B test, but not on this one. Number 78. You have a 0 of 5 with a multiplicity of 3, and you have a 0 of 0 with a multiplicity of 2. Write the polynomial function that has the zeros and multiplicity, and it's a degree of 5. So, this top one, if you have a 0 of 5, that means x equals 5. So that factor is x minus 5, but it has a multiplicity of 3. That's all you do, make it the power. And then the next one, we have a 0 of 0. That means x equals 0. That is the factor, but it has a multiplicity of 2. So your f of x is x minus 5 to the third power, just a x, but to the second power. So that's how that works. And the degree of 5, there's 2 of them, and there's 3 x's, so that's an x to the 5th. It all matches and it all works. That degree of 5 is just to help you make sure your exponents will give you a 5. I think that's it for that section. So that brings you to 2.3. And in 2.3, you need to review long division, synthetic division. I didn't do anything with the remainder theorem. And you need to review rational zero test. And then you need to look at 2.4 with your complex numbers. But I'm hoping that shows you how a little bit more of how I want you to study for your test. You sit down and you work problems, and you look at the directions from the homework, and, oh, those directions sound like the type of problems she did today. Let me try some of those. And then you're not flying blind because you've worked these before. You have them back in your notebook. This is where staying organized really comes in handy. All right, good luck. I'll be in my room in the morning. If you get stuck, you can email me and I'll try to check for you today.